So now just see this question. Give electron dot diagram of the following. Okay. So to do this question, it's a pretty simple question. To do this question, basically we are in need of three prerequisites. Okay. So what are those? Prerequisites to solve this particular or to understand this particular concept. So first is that this noble gas configuration. First, what is noble gas? So it is what? Helium. Helium is your noble gas. Okay. One is your what? Neon, and another one is your what? Argon. Okay. So what? Helium is what? 2 electron. Neon has what? How many electrons? 10 electrons. And this argon has what? 18 electrons. Okay. So what is the electronic configuration of this helium? It is what? 2. What is the electronic configuration of this neon? It is what? 2 and what? 8. And what about this argon? It is what? 2, 8 and what? 8. Okay. So this is what your noble gas configuration. All right. Okay. Now the second thing is that we have to see the electronic configuration of these elements. We must know. So how many elements are present in these compounds? Look at this. This is what your magnesium. Then here it is what? Chlorine. Then it is what? Nitrogen. Then it is what? Methane. In methane, the formula for these, just write the formula. This is what your MgCl2. This is what your N2, and this is what your CH4. So we have 5 elements, okay, in these 3 compounds. Okay, so this is what your one is what your magnesium. All right. So one is what your magnesium, and what is the number of electrons in magnesium? It is what? 12. So this one is the electronic configuration of magnesium is what? 2, 8 and what? 2. Okay. Now you have chlorine. Chlorine is what? Again what? It is what? 17. So what is the electronic configuration? 2, 8 and what? 7. Okay. Now what about this nitrogen? So nitrogen is what? Again 7. So it is what? 2, and in second cell it is what? 5. Okay. Then is what? Carbon. Carbon is what? 6. So in first shell it is what? 2, and in second cell the rest 4 electrons. Okay. And then it is what? Hydrogen. Hydrogen is what? 1, and then it is what? Just 1 electron in first shell. Okay. Now we are going to see another concept, that is what? Valence electron. Very simple. Valence electron. And valence electron, the electron in outermost shell. So this is what your first shell, this is what second cell, and this is what is third shell. So this one is your outermost shell, that is your third cell. And in third cell, how many electrons are there? 2 electrons. So valence electron for magnesium is what? Again what? It is what? 2. For this chlorine, you can see third shell 7. So it is what? Valence electron is what? 7. Okay. What about this nitrogen? 5 electron in outermost shell. So valence electron is what? 5. Okay. What about this carbon? Number of electrons in outermost shell is what? 4. So valence electron is what? Again 4. All right. And this hydrogen. Okay. So this is what? 1. Okay. Now the next concept is what? Lewis symbol. Okay. Next concept is what? Lewis symbol. Again, very simple concept. What you have to do when you are drawing this Lewis symbol, just what you have to do, just pick that particular element, okay, and write the symbol of that element. Suppose we are talking about magnesium, so write the symbol of magnesium, then see the valence electron and put dots, as many valence electrons. So put 2 dots here. So this is what the Lewis symbol of what? Magnesium. Okay. You can use cross also in place of what? Dot. Okay. Whatever you want. Okay. It's just your choice. All right. So in case of chlorine, what should be the Lewis symbol? Okay, tell me. So this is what your chlorine, and how many valence electrons? 7. So you have to put what? Suppose if I want to put here, so it is what? It is what? Cross. Okay, so 7 cross around chlorine. All right. So this is what the Lewis symbol of what? Chlorine. Okay. Next, nitrogen. Very simple. You have 5 valence electron. Symbol of nitrogen is N. So put what? 5 dots around N. Again carbon, same, 4 dots around carbon because 4 valence electron, and this is what your hydrogen, 1 dot. Okay. Okay, so now it is we have seen this Lewis symbol, we have seen this valence electron, and we have seen this electronic configuration of certain elements as well as the noble gas. Okay. One more thing, that every element wants to achieve its nearest noble gas configuration, either by losing electron, or by gaining electron, or by sharing electron. Okay, by sharing electron, by sharing electron. Okay, by sharing electron, and by sharing electron to achieve what? To achieve nearest noble gas configuration. Okay, nearest noble gas, nearest noble gas configuration. Okay, configuration. All right, so now who will lose electron? So generally metal has a tendency to what? Lose electron. Okay, and who will gain electrons? So generally non-metal has a tendency to what? Gain electron. This non-metal has a tendency to what? Gain electron. Nm stands for what? Non-metal. Again, sharing electron, this is again a tendency of what? Non-metal. Okay, so what if suppose in a compound if you have metal and non-metal, so what will happen? This metal will lose electron and this non-metal will what? Gain electron. And if suppose you have non-metal and non-metal in a compound, okay, so in a molecule, so in that case nobody is ready, neither this particular non-metal or this particular non-metal is ready to what? Lose electron. Both of them, okay, both of them wants to what? Gain electron. But if someone wants to gain electron, someone has to what? Lose electron. So in that case these first two possibilities are not there. Okay, so the third possibility, look at this third possibility. So then they will what? Then they will what? They will share electron. Okay, this is the concept. Now this question is conceptually, this question is what? Over. Okay, so now we will draw one by one. Okay, now we will draw what? One by one. Let me just okay, these everything written is what? Just your concept part. Okay, so now what is the funda to draw the electron dot diagram? So first you identify the elements. Okay, so you have what? You have how many elements you have? So you have magnesium. Okay, you have what? Chlorine. We are doing A part. Okay, and you have chlorine and you have two chlorine, so it is what? Magnesium one. So what you have to do? Then draw the Lewis symbol, and Lewis symbol is what? This is what your magnesium, and this is what your two dots. All right, and chlorine, and this is what your seven dots, and this is again what your chlorine. Okay, so this is again what your seven. Better to write cross. Okay, so that we can discriminate between the electrons of magnesium and chlorine. Better, that's why we are using cross here. Okay, okay, so this is what your seven electrons. All right, so as I said earlier that everyone wants to what? Achieve its nearest noble gas configuration, and because magnesium is what? Metal, and the nearest noble gas to magnesium, you can see the periodic table, it is what? Neon. Okay, so it will lose what? These two electron. So and what about chlorine? So chlorine is what? Non-metal. The configuration of chlorine is what? 287, and it wants to achieve the nearest noble gas, that is what? Argon 288. So in that case chlorine has to accept one electron. So what it will do? Very simple. Okay, look at this. Even you can, now you can understand. So it will gain one electron from this, I mean this magnesium, and this particular chlorine will gain what? One electron. Okay, so now what will happen? So now important thing is that this magnesium lose two electron, and then it what? Achieved the nearest noble gas configuration, that is what? Neon. Okay, and these two chlorines achieved the nearest noble gas configuration of argon by gaining one electron. Okay, so what will happen? Magnesium lost two electron. So what will the charge on magnesium? It will what? Plus 2. And what about this chlorine? So chlorine is what? Chlorine is gaining one electron. Okay, chlorine, this chlorine is what? Gaining one electron. So it has what? 7 valence electron, and because it is gaining one electron, so it has what? A negative charge on this. Okay, and you have how many chlorines? 2 chlorines. Okay, so put 2 here and put it in bracket. Okay, put it in bracket. So this is what your electron dot diagram of what? MgCl2. Okay, now see, the second part was what? Second part was what? Your nitrogen, N2. So look at this. We are going to see this particular N2. Okay, your B part is what? Your N2. Okay, so this is what your N2. How many atoms of nitrogen here? Suppose one atom, and this one is what? Again what? One. Okay, now look at this nitrogen. Both are what? Non-metal. Okay, and nobody is ready to lose electron. Nobody is ready to lose electron. Both are ready to what? Either gain electron or if someone is ready to lose electron, then they will what, gain electron, or they're ready to what, share electron. Okay, so in this case they will what, share electron. How they will share electron? So first write the Lewis symbol. All right, so this is what, 5 electrons here. All right, 5 electrons, and this nitrogen has what, again 5 electrons. This nitrogen had what, this nitrogen has what, again 5 electrons. Okay, so this, now look at this. Now look at the configuration of this nitrogen. Look at the configuration of this nitrogen. It is what, 2 and 5. So if it wants to achieve its nearest noble gas, that is what, neon, so it is in need of what, it is in need of what, how many electrons? It is in need of 3 electrons. Okay, so both nitrogen is in need of what, 3 electrons to achieve its nearest noble gas, and that is what, your neon, that is what, your 2,8. Okay, 2,8, and this the electronic configuration of this nitrogen is what, 2 and 5. Okay, so what it will do, just guess. Okay, it's pretty simple. This nitrogen, this will what, they will share what, these 3 electrons to each other. Okay, so what will happen now? Now these 3 dots are the part of this nitrogen, this red nitrogen also. Okay, and these 3 crosses are the part of this blue nitrogen also. Okay, so now you can see. So let me draw again. So this is what your nitrogen, this is what your 3 dots, and this is what your okay, make it red so that you can discriminate between these 2 nitrogens. Okay, and this is what your cross. Okay, and what is happening here, this nitrogen is what, sharing these electrons, and this nitrogen is what's sharing these electrons. All right, so now you can see both nitrogen has what, now the important part is there, these 3 electrons, not, it's right now it's not the part of this nitrogen, this red nitrogen. Okay, okay, it is the part of this blue nitrogen also. Again, these 3 electrons are, the part of this blue as well as this red nitrogen also. Okay, so look at this blue nitrogen, how many electrons? So this is what, 1 and 2, and these 2 electrons are solely responsible, or these 2 solely belongs to what, this blue nitrogen. Then again what, 3, 4, 5, and as I said you earlier, these red electrons are also the part of this blue nitrogen. So this nitrogen has what, 1, 2, 3, 4, 5, 6, 7, and 8 electrons in their outermost shell. So it achieved the nearest noble gas configuration. Again, the same case about this nitrogen. So this is what the Lewis symbol of what, this N2. Now we have what, C part is what, CH4. So first draw the Lewis symbol. This is what, 1, 2, 3, and what, 4. This is again what, hydrogen. You have 4 hydrogens, so draw this. Okay, 4 hydrogen. All right. Okay, now look at this. What is the nearest noble gas for hydrogen? It is what, helium, and it is what, 2 electrons. And what is the nearest noble gas? It is what, again neon. For carbon it is what, again neon. So carbon is in need of what? It should have what, 8 valence electron. Now it has what, 4 valence electrons. So it is in need of what, 4 more electrons. It is in need of 4 more electrons. And what about this hydrogen? They have 1 valence electron, and it is in need of what, 2 electrons, because what, nearest noble gas is what, your helium. Okay, so this one is in need of what, 4, 1, 1. Each hydrogen needs what, 1 electron to achieve its nearest noble gas configuration. Now it's pretty simple, even you can guess. Okay, so look at this carbon. Okay, look at this carbon. So this is what, your 4 electrons. All right, and look at this hydrogen. Make it black. Okay, make it black. So okay, make it black, that's better. Okay, make it black, and put it cross here. Then again 1 hydrogen, put it cross here. Then again 1 sorry, this is hydrogen, sorry. So this is again, put it 1 cross here, and this is again what, hydrogen. And what to do? So this hydrogen needs what, 1 electron. So give this 1 electron to this hydrogen, and this, in this circle there is 1 symbol. In one circle there is 1 symbol. It's not circle but look like circle. Okay, so in this particular enclosed, you can say enclosed area. Okay, so hydrogen, the symbol, and how many electrons are there? 2 electrons. So whatever the electrons in this enclosed circle belongs to what, this symbol, that is what, your hydrogen. Okay, this so hydrogen has 2 electrons, that means it achieved the nearest noble gas configuration. Now what to do next? Again hydrogen. Okay, so it will, again, what about this one? So again what, this one. Okay, So every hydrogen has what now? Now what? Two electrons each, that it achieved what? Nearest noble gas configuration. And what about this carbon? So what it will do? It will share one electron from this all hydrogens. So what will happen? What will happen? So basically now, so this is what an enclosed area in which you have one symbol, and look at the symbols, how many electrons are there? 1 2 3 4, and this is what again 5, this is again 6, this is what again 7, and this is what again 8. So even carbon achieved what? Its nearest noble gas configuration, because it has valence electron. Now it has valence electron what? 8. Okay, so in this case, this is what your diagram. Okay, this is what your electron dot diagram of what? CH4. Okay, okay. And in this case, because carbon and hydrogen both are what? Non-metals, so in this case sharing is what? Taking place. Okay, hope you understand. Okay.